Welcome to another version of the NDSU Extension Nutrient Management online Moodle training. I'm Ron Wiederholt, the Nutrient Management Specialist at the Carrington Research Extension Center, and I'm going to share with you today some information about how manure behaves in the soil and how that behavior can impact crop production. One of the questions that we get a lot when it comes to using manure as a fertilizer is the question of timing of the manure application. Does that timing impact the crop yield? How can we answer that question based on knowledge that we know? In the past, there was a simple answer to this question that if you aren't concerned about runoff, you can apply the manure in the spring or the fall. But if there is a runoff concern, then you want to apply it in the spring only. However, in the upper Great Plains, where we have a broad range of crop rotations, can the slow release of the nitrogen in the manure be a problem when you're applying it for a crop that has early season nitrogen needs versus a crop that has long season nitrogen needs? To try to answer this question better, we initiated a simple trial at the Carrington Research Center in 2008 and repeated it again in 2009 to take a look at the behavior of a fall applied, spring applied manure and a spring urea applied fertilizer. We used wheat as the test crop because wheat is an early season end user and needs the fertilizer within the first 6 to 8 weeks from germination. Getting right into the results of this study, when we combine the 2 years of data that are shown in this chart, we can see the bushels of wheat per acre are on the vertical axis and the treatment is on the horizontal axis. When you look at these treatments, you can see that the urea treatment did significantly out-yield the check and the spring manure, but was somewhat similar to the fall manure. The fall manure did yield higher numerically than the spring manure and significantly higher than the check. Not only did we see an impact on the yield of the wheat based on the fertility treatment, but we also saw an impact on the protein. In this slide, we have the percent protein on the left-hand column and the treatment across the bottom, and you can see that the urea statistically yielded higher than the check, the fall manure, or the spring manure, and in fact, the fall and the spring manure behave similarly to the check. So the lack of early season availability of the nitrogen in the manure also impacted the protein of the wheat. Another way to investigate this a little closer is to look at the economics versus just straight out yield of the crops. If we look at the cost of fertilizers, urea around 470, anhydrous around 415 per ton. You can adjust these always based on the year-to-year basis, but for this analysis, these are the costs that we're using. When we try to determine the value of the manure nutrients, one way to calculate that is based on the cost to apply it. At the Carrington Research Center, we have the manure applied by a custom operator as shown in the photo on this slide. And if we calculate out the cost that we have in per acre divided by the analysis of that manure, which in this case it was analysis of 7 pounds of nitrogen, 7 pounds of phosphorus, and 10 pounds of potassium per ton, we came out with a value of $64 per 25 tons of manure applied per acre. When we compare the cost on a per unit of nutrient basis, you can see that the commercial fertilizer costs on this chart are anywhere from around 30 cents a pound for urea up to 45 cents a pound for anhydrous, whereas the manure nutrients, the nitrogen, the phosphorus, and the potassium in the right-hand side of the curve, are all around 11 cents per pound. So there's a significant price difference between manure that is applied commercially versus commercial fertilizer. Now you also have to take into account the manure application. This includes the application cost, whereas the commercial fertilizer, this is just the cost of the fertilizer. We haven't added in any type of application costs. So even though we lost a little bit of yield using the manure as a fertilizer, did we make up for that yield loss by using a cheaper fertilizer source? Now to correct the wheat for protein, if we look at the $4.20 base wheat price, we can see a differences in price based on the protein from $5.70 a bushel, which is the high protein of the urea, down to $4.80 per bushel for the 13.9% protein for the check. Using the known information that has already been presented, we can tabulate the return or the gross dollars per acre of the yield based on the actual dollars per bushel of the wheat, and then subtract the commercial fertilizer or the manure fertilizer costs to come up with a net dollars per acre return based on just those simple expenses and economics. In this table we have the economic factors down the left-hand column and the treatments across the top, with the yields based on each treatment in the first row, the dollar per bushel corrected price of the wheat in the second row, and the gross dollars per acre, which would be the yield times the dollars per bushel in the third row. And as you can see, the urea had the highest yield, which obviously gave us the highest gross dollars per acre because it also had the highest dollars per bushel based on the protein. The fertilizer cost in the fourth row in the dollars of nitrogen per pound, we're just looking at nitrogen in this example. The check had no fertilizer applied, so obviously the cost is zero. The urea, based on the values we used and the pounds per acre we applied, was a little over $67 of nitrogen per acre. The fall manure and the spring manure had the same cost based on the application rate and the application cost. If we subtract that fertilizer cost from the gross dollars per acre of the yield and the protein, the check returned us $141 per acre, the urea $206, the fall manure $226, and the spring manure at $181. Now here you can see that the lower cost of the fertilizer, even with the lower yield of the fall manure, we returned a greater net per acre. Another way to look at this is to compare that return per acre over the check. In that situation, the urea gained us $62 per acre over not using any fertilizer. The fall manure application gained us $83, nearly $83 per acre over not using any fertilizer. And the spring manure, which had the lowest yield of the applied fertilizers and the lowest protein, only gained us $37 per acre over the check. The numbers from this study conclude that the timing of the manure application can have a negative effect on nitrogen availability, but probably not profitability, especially for crops such as hard red spring wheat that has a high early season nitrogen demand versus a longer season crop such as corn. So manure does have special management considerations. If you're using it as a sole nutrient source, it can be a complete substitute for commercial fertilizer. However, that depends on the crop that's grown. All the research that we've done at the Carrington Research Center agrees with research done throughout the nation that if you're applying manure as a fertilizer source on a long season crop such as corn, you can substitute that manure for a commercial fertilizer completely without any concerns. However, the work we've been doing in the upper Great Plains shows that a short season crop like wheat that has a high early season nitrogen demand, timing will have an impact. You would want to apply that manure in the fall, and if you wanted to get similar yields to a commercial nitrogen source, you may want to apply a low rate of N at planting, maybe 20 to 30 pounds per acre, just to give it a boost before the manure nitrogen is mineralized. So using manure in a cropping system is economically beneficial versus commercial fertilizer, but as long as you understand the behavior and take that into account. However, just because you're using a cheap source of fertilizer like manure, you cannot make more money if the yields are compromised. Therefore, it's still important to sample that manure and calibrate the spreader so you know not only the analysis of the manure, but what rate it's being applied, so you're applying it at the proper rate for good crop production.